Welcome to part 5 of Competency 19. In this video, we will work problems that make math connections using our TI-84. Number 1. Mark is teaching his first-year algebra students how to factor quadratic equations. How could he show the class a quick way to multiply 61 times 59 by using the difference of squares? Okay, you can tell by the options if you don't remember what difference of squares is. If you don't, you might want to stop the video and Google that real quick to refresh your memory. But the best way to tackle this one, okay, is to think of what's in the middle. What is in the middle of 61 and 59? Well, obviously, that would be 60. Okay, that's telling you that you can have plus 1 minus 1. Okay. All right, if you can have plus 1 minus 1, let's see what happens. Well, that would give us 60 plus 1 and 60 minus 1. And that fulfills the requirements for difference of squares. Okay, because what's really going to happen? You're going to have that 60 squared, okay? And then you'll have plus 60 minus 60 and then minus 1. Okay? So let's see what happens to that. Well, this is going to be 0. And then if we put this in our calculator, 60 squared, right, minus 1, okay? And I don't know, in my opinion, if that's actually easier. I guess it is easier for a student if they're doing it by hand. It doesn't make sense exactly to all students with the actual difference of squares equation. But if we take a look at what happens to that, we do get, if we look at, let's go ahead and multiply that out, 61 times 59. Okay, we get the same answer. So I guess to figure out which one of these is appropriate, because, oh, here, sorry about that. Well, okay, there it goes. Okay, so our options all begin the same with the difference of squares, basic general equation, and looks like what we wanted was a 60 plus 1 and 60 minus 1. Well, that's C. Okay. B doesn't make sense because when you multiply that out, that's just not going to be, I can tell by looking at it. Here, let me show you what B would look like. You can put that in a calculator for yourself and take a look. If we subtract out what they have there, that makes no sense whatsoever. So B has to go. And then A doesn't make sense because this 61 minus 61 squared, that won't work either. If you've worked with the difference of squares, you know that is not how it lays out. It's not going to factor or multiply back together like that at all. Okay, then if you look right here, if the 61 squared and the 59 squared, this does not equal this. That's one of the first things we learned in algebra. And you can pop it in the calculator to check for yourself, but that should be something basic that you just remember from algebra. So C is going to work, and let me work that out for you. this actually does equal this because this is 0. So what we're going to have is 60 squared minus 1. Well, let's see what happens. 60 squared minus 1. And there you go. The answer we want. Okay. All right, let's look at number 2. Okay, we will not need the calculator for this. I can see it right now. This is just to have you worked with algebra squares before. Can you make sense of them? Okay. So number 2, James asked his students to use algebra tiles to demonstrate that 2x plus 4 times x plus 3. Okay. All right. To demonstrate that factored equation, which image is the correct way to factor? Oh, okay. Factor this equation. I'm not sure why that's spelled out. There we go. Okay. So all you have to do is look for the model that works. So you're going to have, if you haven't done this before, I'll write it out for you. So you should have or you should have 2x. What do I mean by that? You should be able to write at the top and the side. Watch, I'll do all of them. This one, okay, this one is x, x. That's 2x's, x times x. Then plus 4. 1, 2, 3, 4. This one is x plus 1, 2, 3. Okay. And that looks like that's what we want. But I'll do the others for you also. Okay. So let's look at B. B is actually, I know it looks weird, but that is x plus x. And oh, this one's plus x. Sorry about that. X plus x. That's x plus x. However, that's plus 1. And this one, these are not a full x. This one's just 1, 2. Oh, can't tell what I'm doing there. That'd be just 3. Let me just write it out. That's just 3. So that's actually 2x plus 1 times 3. This one ends up being what we need. On the top, we have 2x's plus a 4 times an x plus the 3. This one is x, okay, x plus x plus 1, 2, 3. And then this side, down the side, is x plus 1, 2, 3, 4 plus 4. So that's going to be 2x plus 3 times x plus 4, which you would think is the same thing. When I look at it, it looks like the same model. However, you have to look at which one matches and emulates what they asked for. This would be a great way to see what students come up with, because when we FOIL that, distribute that, you're going to come up with the correct same equation in the end. However, we want A because A is what's asked in the question. Now D is just x plus 3, and this is x plus 1, 2, 3, 4. Obviously, that isn't what we're looking for. Okay. India is an Algebra 2 teacher. She wants to show her students how a graphing calculator can reduce the time needed to solve complicated problems. She solves a problem. Here's our problem. What is the solution to the equation? Okay. This, if you notice, you're going to have 3 values of x, and this is your leading exponent is to the third power. So that means you should have at least one real solution and two imaginary. And that's what our option gives us. Okay, I know that you're probably looking at that and you're saying to yourself, how on earth do we solve this? Well, if you know how to use your TI-84, it's not a big deal. Okay, what we're going to do is we're going to use our apps, okay? So push apps. You'll see right there, it's APPS. Push apps. Okay, and what do we want? We've learned how to do finance. We don't want this. We don't want conics means circles and things like that. What we want to do is we want to go to number 9. Okay, and we are working with number 1. That's polynomial root finder. Okay, so that means we can have higher order polynomials higher than the second power beyond your quadratic. Okay, well, mine is set on what order do we want? I don't want second order. I want third order because I have that 3 there. Okay, now this calculator is set for real. Nope, my answers want more than the real solution. They want all the solutions. So I have to go to my real option. Okay, that's showing my imaginary. I'm sorry, not real option, but my imaginary. So I'm clicking on it, see that? Don't worry about auto, normal, float, and degree. We don't need that. We're just focusing on this kind of problem. Okay, now we need to push, we need that next. So we push graph, and then we need to put all this in. Uh-oh, it just did a second order. Oh no, we need to go back to main. Okay, let's enter number 1. Oh, I didn't enter it. That's on me. There we go. Lesson learned. Now push graph again because that's what we need for next. Okay. Now everything's where I need it. Okay. Well, they already have a 1 in as the leading coefficient. I'm fine with that. And as you push enter, okay, it should enter order over. And if we had any negatives, we could put in negative if we needed to, but we don't need any negatives or subtraction. Okay, so I arrow over. Now I need a 3. Okay. All right. Now, okay, I'm going to go, oh, plus is fine. So arrow over. And then I need a 10. All right. Push enter, arrow over. And then I need a 16. Okay, notice you have to push enter. So it's all set up. Now, all we have to do is push solve, which means I have to push graph. Okay, there you go. That's what we need. That's our answer. That easy. It's amazing what a TI-84 will do. Okay, so we need a -2 for x1. Well, this is not it. This is not it. Now, be careful when you're selecting. It says that for x2 and x3, the first part of those values is a -0.5. Well, our option has 0.5, same thing. Well, that's a negative and that's a negative, but it's for both. See here, we have x1, he's check. Now, this whole thing is x2. So we need negative, negative. That works. Okay, what about this one down here? Negative, negative. Okay, that's checks. That checks. Okay. Here, let me undo. So that's confusing. That one checks. That one checks. Now, wait a minute. Yeah, I probably ought to. Okay, this part checks. Now, let's look at 3. It has a -0.5, then a positive imaginary portion. Okay, so B will not work, but looks like D does because look, it has -0.5, then plus for our imaginary portion. There you go. All right, or a complex portion, we could say. We say imaginary. All right. Number 4A. In an algebra class, students are using their graphing calculator in a self-discovery to determine the fastest way to solve a system with two equations. Okay, we have our system, 3x plus 10y plus 16 equals 0, and x plus 7y plus 13 equals 0. What is the solution to the system? Okay, this is real simple in our TI 84. What we need to do is push apps, number 9, then number 2, and we have two equations. So we arrow down and we have two unknowns, x and y. And everything else we want to keep as is. It doesn't matter about radians and degrees. So what we push is right below the next, we push graph, and that'll get us to the solving. Okay, now we need to put in, for our first one, we had 3x. Make sure you push enter, and you'll have to push it twice. Why? Because see where it's highlighted? You can have a negative situation. Luckily for us, everything is on the positive, so we're good to go. Okay, so push enter again. Now 10, enter. Okay, now notice that the constants are on the other side of your equal. So this means I'll have to take my 16, put him over here on the other side, but he will have to be negative 16, just like you learned when you were in algebra, however many years ago that was, a long time for me. I was taught by a very nice lady named Mickey Miles. Okay, so as Mickey Miles tells us, we need to put a negative 16 on that side and enter. Now we're on our second equation. See where it has 0? You can have 0 there, meaning that you had two variables in the first one, but not in the second one. That's not our case. We actually have an understood 1 right here. So we need to type in 1, enter, enter, because we had positive 7y, enter again, and negative 13. Okay, now we're ready to solve. Okay, push graph again, and there are our values. And as we can see, for our x value, we need 18 over 11. Well, that's not A, that's not B, because that's negative. C won't work. This gives us option D. Okay, this is going to be the last question in this video, and thank you so much for watching. I've gotten some positive comments, and our next video is going to be part 6, and we'll take up with number 4, part B, which will be a variation on this particular equation. Thank you for watching. Thank you for subscribing and sharing and liking us. Happy testing!